Question 22. A network of pipes with one cut is shown. The number on each edge gives the capacity of that pipe in litres per minute. What is the capacity of the cut shown? So when we look at the cut, we want to see the flow that's going through it. And so what I like to do, if this is our starting and this is our finishing points, we want to see the direction that the arrows actually going through the cut are. So this BD line at 26, this arrow is going into the cut. Now, if we look, it actually cuts this DE as well, but this is going out of the cut. And then this EG is getting cut and the arrow is going in. See the arrow at 24. EF is getting cut and the arrow is going out. And then CF is getting cut and the arrow is going in. Now you need to make sure all these arrows are on the same side, right? On the left side of the cut. I like to think of it once again as reading a book from left to right. We'll start at the left side of the cut because the flow is coming from the start. The flow doesn't come from the finish, it comes from the start. So you have to look at this side. Now, we only want to count the edges with the arrow that's going into the cut. So that will be 26. 8 is not going into the cut. 24 is going into the cut, so plus 24. 6 is going out of the cut, and 12 is going into the cut. So this will be equal to, when you add them all up, 62, and the network of pipes is given in litres per minute. That's the capacity, so 62 litres per minute. So that's part A, and then part B, I've copied the diagram from part A up here because this is going to be very useful in this question. So it says the diagram shows a possible flow for this network of pipes. Now this is the same network diagram, but some of the numbers are different. And I need you to keep that in mind for the rest of this question. It says, what is the value of X? Give reason for your answer. Now, when I was looking at this question, I noticed that at all of the nodes, the inflow and the outflow were equal. Okay, so if we look at any node, let's say this node B, 18 plus 5 is 23, and they're both going in, and the outflow is also 23. And if you look at any of these nodes, inflow and outflow is equal. So if we want to find X, the X is going into C, and technically it's going out of A as well. However, we don't know what the inflow of A is because this is the starting point. So we're going to pay attention to the node at C. So the inflow of C is just X, and the outflow is 5, 13, and 12. So we're going to go 5 plus 13 plus 12, and this equals 30. Therefore, X equals 30, and my reason is going to be because inflow equals outflow. Now for part II, it says which of the pipes in the flow are at full capacity, and this is where I want you to pay attention to the part A. Now part A, a lot of the numbers are bigger than what the numbers are in part B, this diagram part B. But what we want to pay attention to is which ones in part B are like capped out. So if we look at the question or the diagram for part A, 15 and 15 are the same. 11 and 11 are the same. 8 and 8 are the same. And 12 and 12 are the same. Every other edge in part B has a value lower than in part A, which means that it's not at full capacity. It means that we can have more flow in there if we want to. Like the pipe system, it allows for more flow, but not in these 4 edges. So when it says which of the pipes in the flow are at full capacity, we can say DG, which is this one, DE, FG, and CF. And then for part 3, it says the maximum flow for this network is 50 litres per minute. Which path of pipes could have an increase in the flow of 2 litres per minute to achieve the maximum flow? So we need a path of pipes, which means that we need something that goes from the start to the finish that can all increase by 2 litres per minute. Now, if we want to get to the finish, DG and FG, they're capped out. So we can only go down this path EG. Now from here, the only edges that flow into that aren't capped out are CE or FE. However, let's say we went down FE. After that, you can't go through any of the other pipes that are next to it to go back to the start. So your only option is to go down to C. From here, we can't go up to B because the arrow is in the wrong direction. And the same with going to F, but this is also capped out. So the only path that we can go back down is to A here. So the path that we're going to write here, it says which path of pipes could have an increase in flow of 2 liters per minute to achieve the maximum flow is A, C, E, G. And every one of these can have an increase of 2 liters per minute and it won't overflow. So over here, this one's 22 and up here in part A, it's 24. So if we increase by 2, it's maxed, but it doesn't go over the max. Over here, CE is 13. Up here, CE is 17. So if we add 2, 15, it's not capped. And then for AC, we said that it should be 30. And if you add 2 to that, it's 32, which is lower than 35. So everything works out beautifully.